All right, so this is Module 7. So when you finish this module of learning, you're going to be ready for Test 2. And after Test 2, you'll be right at the halfway point of the semester in terms of weeks. So this week is going to be acid reactions and acid strength. And then it's going to be learning how to solve for any of these terms on top, pH, POH, H3O plus, and OH, and then as well as how to calculate strong acid pH. Now, this is a building week, and by what I mean by that is that, yes, this is going to be on test 2, but the information you learn in this week won't go away. So one thing is the acid reactions over here. You're going to learn about Arrhenius, Bronsted, and Lewis, and most of the reactions that you're going to be dealing with for the next few weeks are going to be Bronsted. And you're going to be needing to recognize what happens when an acid and base reacts, as well as when with an acid and water or a base and water. And you're going to need to be writing these reactions. It'll happen several times coming up. The other one, this acid strength, this is more trend based, and where this comes into play is the stronger the acid, the larger the Ka. But weak acids, and that's what most acids are, there's only 6 strong ones. Weak acids all have a small Ka. It's just they get really, really small the less strong they are. For the most part, we're going to be using acid Ka charts, and so you'll be able to actually obtain the value. But I'm just letting you know that just having a sense of these trends can be helpful. It's also kind of like a favorite question, this ranking things. It's an easy, fast type of question for the cumulative, the ACS exam. So that's another thing. Just it's a popular topic. When we go over here to these equations, these are the equations. You'll notice a lot of similarity between the first two right here. It's just switching out an H and H3O plus for an OH and an OH minus. So it's kind of the same. You want to be real careful doing those calculations. And not written down, but also part of this is being able to go from pH to H3O plus. And this is a log method to do this. Like it's a logarithmic rule to be able to do that conversion. So you'll learn about that. And then you'll learn about why these two times each other are going to give you 1 times 10 to the minus 14th. Finally, you're going to be using the information that if there's 1 OH in there, it's 1 mole of OH per 1 mole of an AOH. If there's 2, then there's 2 per 1 mole of BaOH. And you can use that as a conversion factor. If you already know the molarity of the BaOH, like say it has a molarity of 2.0, you can use it to convert from the value for BaOH2 and convert it straight into OH. And the whole reason you'd want to do that is because you'd want to be putting it in there and solving for POH. Oh, and there's one other equation that wasn't shown in here. So 14 minus the pH is equal to the POH, and likewise 14 minus the POH is equal to the pH. And let me just show you why where you're going to see this coming up again. Right in here, pH equals negative log of H3O plus. Right in here at the bottom, pH equals negative log of H3O plus. And those are shortened examples. It also has the POH in there too. Over here, there's a different equation. This is not the same one, so this one section doesn't use it. But then I'm going to go back over here, and these titrations use actually what I was just talking about, just the straight up pH equation, and it also uses the pH equation in different formats. So those are not going away. So just make sure and practice it. Be real confident with them.